we can check actually if you didn't start.
This one here?
The broadcast is now starting. All attendees are in listen-only mode.
What do I press that one for? Show my screen. Star one, wasn't it? Can you hear me over there? And do I have to go down here for this one? Hello, if anybody's listening, we're going to start in just a few minutes. David Wood here, and we're just checking, seeing everything is working fine. And we don't have to press star one on that. Let's try. Hello? Hello. Sorry, can't hear you. It's rather quiet. Is that? Let's see where we are now. Can you? One can barely hear. What should I do? Press this button here. Hello. Is that any better, gentlemen? The gentleman who cannot hear. Hello. Can you hear me any better now? Is that any better? Better. Thank you. Better. Good. Wonderful. Okay. Yes, better. Thank you. Thank you, Rashad. Thanks. Great. Lovely. Yes. So I think we're about at 2 o'clock now, or we have a kind of church bells here near the office, and they're just ringing 2 o'clock, gentlemen. So we'll be with you shortly. Okay, gentlemen, let's begin our webinar. My name is David Wood, and I'm coming to you from the DVB project office here in Geneva. And with me are my colleagues, Desiree and Feo. You might know them. And we have a webinar now. We're going to explain what the situation is in the project about our work on 3D TV. Hope you find it's useful. Here's just a few pictures to, I hope. Here's just a few pictures to kind of put you in the mood. You know, it's all about people wearing glasses, isn't it? But the system itself is quite old, in fact, and you need, of course, special cameras for all that. That was just to get you in the mood. One of the things that people do ask us is about who is doing what in terms of different standards bodies in 3D television, and sometimes it seems as if there's some kind of chaos. But actually, it's really quite organized chaos. So here's a brief look, first of all, at who is doing what in 3D television standardization right now. And the DVB project, us, we are, as we usually do, developing broadcast signal formats, the things that go out over the airwaves. The body, the SMPT, the Society of Motion Picture and Television Engineers, is developing the studio end of things. They're developing a file format for 3D TV production, so there's no conflict, and we're keeping in touch with them, of course. And the MPEG group are developing compression systems. And as you'll see in a few minutes, these are largely compression systems for what we call in the DVB project Phase 2 systems. Now, there are two other bodies that you might like to know about. One is called the 3D at Home Consortium, and you can find them because they've got a website. And one of the interesting things that they're looking at is to do with the use of glasses, the glasses that you need with a special 3D TV display. What we hope is that at some point, one set of glasses that you buy with one manufacturer's set will work with another. So that's the 3D at Home consortium, and they're looking at this business of interoperability of glasses. And finally, there's a group of the European Broadcasting Union, if you're in Europe, which is a mixed group of broadcasters and manufacturers, and that's a group looking at requirements. In addition to all that, and I suppose we have the ITUR, the International Telecommunications Union, that kind of sits back, waits for other people to do things, and then tries to see if it can make worldwide recommendations out of them. So I guess those three groups above may find themselves eventually in ITU recommendations for 3D television. One thing that's not being done, if you're interested, is, I guess I believe that it should be, is to look at guidelines for program making in 3D, because a lot of the quality of 3D depends on how you make the program. And so wouldn't it be nice if there could be somebody working on guidelines for reduction grammar? I don't think that's the case at the moment. But as far as all the rest of the things are concerned, as you can see, these are quite good pieces of a jigsaw puzzle that are coming together, and coming together quite well now. Let's have a look at the next item, which is about commercial requirements. And you know this, don't you? But what are commercial requirements? Well, they're factors that may affect or determine the success of the system, and they include things like cost, features, complements, and so on. And essentially, commercial requirements answer this question of what does the system need to do to be successful. So this is the first step, and this is what we're doing right now in the DVB project. Ask, what does the system, the 3D TV system, need to do to be successful? And we have a kind of standard process in the DVB project, and it works like this. First of all, the commercial module works out what the requirements are, what we've just spoken about. Then they pass that over to the engineering group, the technical module, and these people are then locked in their bathroom and not allowed to come out until they've found a technical solution, and then it comes back to the commercial module to see whether it meets the needs to be successful. That's the process, and right now we're quite a way through the commercial requirements, and we've started work on the technical requirements, and you'll see how quickly that's progressing, I hope, this afternoon. So this is about essentially work in the commercial module on the requirements. What did we have to work with? Right at the beginning of the year when we started, one of the things that we could turn to was the classification system for 3D television that's been developed, and was developed last year in the ITU. And this is the table that you find in the ITU document. If you want a copy of the report, go to the ITU website, and you'll probably be able to get it there. And if you have any trouble, let us know. But you'll see this is what the ITU, the administrations of the world, believe is the fate of 3D television. You see along the bottom there are three blocks. One's called first generation 3D, second generation, and third generation 3D. Yeah, these are generations of technology which may come out of the laboratories over periods which might be something like 10, 12 years each. Yeah. So what we have is first generation for a period of time, and then when the technology allows a second generation, and similarly for the third generation. And the first generation is called plano-stereoscopic. That means you have two pictures, a left and right picture. The second generation is called multi-view, so you have a lot of pictures, and as you'll see, this allows you to move your head more easily. And the third one is based on recording the light wave, called an object wave profile. But these second and third, well, we don't have to worry too much about them, because these are going to be 10 and 20 years in the future when they come out of the research laboratories. What the commercial module has to do is to look at first generation systems, these systems which have two pictures, left and right. And then if you look at that first column, you'll see that there are 4 blocks in it. Yeah? And these 4 blocks represent levels of complexity of reception, essentially. So it's not unlike the system that's used for MPEG. And the level 1, the bottom one, you see is called conventional high-definition display compatible. I should say that all of this world of 3D television is seen as being a world associated with high-definition television. So that's a prerequisite. The bottom, the level 1, is about conventional display compatible, and this means that this is the level that you would use if you don't want the viewer to buy any new equipment at all. You want him to use the TV set he's got today and the set-top box. Yeah. Now, if you move up to level 2, you'll see one which is called conventional HD TV frame compatible. Now, what we suggest is that for this level, the viewer has to buy a new display, but keep the existing set-top box. So you've got one extra dimension of complexity there in the frame compatible in the level 2. So this is the level 1, don't buy anything new. Level 2, buy a new display but not a new set-top box. And for level 3 and 4, there are different ways of doing it, but essentially this is the layer when you need a new display and a new set-top box. So it's going up in levels of the amount of new equipment, if you like, that the public needs, from none through no new set-top box to 2 different ways of putting technology in a new set-top box. So that's essentially the column that we were working on in the commercial module, and that's what we asked ourselves, for which of those is there a business case? Yep. So we had our early meetings, and we're talking about first generation 3D TV, as you know, with left and right images, and this is just again, to get you in the mood, rather than showing you a diagram with lots of light rays and so on and formulas, I thought you might just like to see it, this picture, which is actually taken in our house here in Geneva. That's my wife there, and you can see by the very small house how much of a raise in salary I need. But it's quite a well-framed stereo picture, and if you're interested in these kind of things and you look at a left and right picture, you can tell which is the left one because the objects on the left-hand side of the screen, you have slightly less of them. So this is kind of rule, less of the left in the left. So this is the way you can tell which is the left and which is the right picture of a stereo pair, which is what this is called. And we take these 2 pictures, of course the television set superimposes one on the other. And the apparent depth that you see in the picture depends on whether the objects, the same objects which appear in the left and right pictures, are in the same or different positions. The further back you go in the picture, the more apart the objects become. So here's the resulting picture, and this is the kind of picture that you get with the shutter glass system. You see, if you look at that little lampshade in the background, it's quite away. There are 2 of them. I guess you could get the idea, don't you? The further back you go in the picture, the more apart the objects in the picture become. And the brain and the eye thinks or sees these 2 objects as it would see a real-life object, because they would be in that position, and therefore it makes the assumption that these are real objects. So without going into the maths, we can do that if you want, or the ray diagrams. This is essentially how it works. And just for you, here's another picture which was shot with a lady. I have no idea who she is, but she was in the square, Lugano, a town near here. And you can see that if you look at the bottom picture, the one which is the composite that you would see on a shutter glass picture, you'll see that she is almost in register. That's to say that there's no ghosting associated with her, and this is because she is almost in the plane of the screen if you were watching that. So again, you see the objects, the further back they go, the more they are distant when you see the composite picture. So that's essentially how a stereo TV works. You probably know that, but just a little refresher. And here's a little bit of vocabulary, not too much, I promise. When an object is apparently projected forward of the screen plane, then this means that we call this negative parallax, and in this case the object that the right eye gets is on the left side of the left eye object. Don't worry about noting this down, but after you're working this for a while, it becomes pretty obvious, all this. And then if the object is in the screen plane, we call this 0 parallax, and this is the place where the objects in the left and right picture are in register. And then if it's behind the screen plane, we have positive parallax, and here the right eye object is on the right side. So you get the picture. I hope that it's about the difference or disparity between objects, the same objects, in the left and right picture. So there we are. That's how it works. But here's something that is very important to remember, and that is that the process of fusing them when you look through the glasses at the screen, it's not something that everyone, absolutely everyone, can do. And there is a reason for this, and that is that our first generation 3D TV, when we get to the third generation, we'll be okay. It doesn't have one piece of information called the object wave phase that allows the viewer to focus on what it perceives to be the position of the object. It has to focus on the screen plane because the light wave is emanating from your television screen, but it has at the same time to point in the direction of where it thinks the object should be. So what viewers of 3D television have to be able to do, is to separate the pointing and the focusing of their eyes. This is not too bad. There are many people who can just do this and look at it and it happens. But there are a few people, and I'm not sure what the percentage is, but some people say around about 5%. Some people do it easily, but a proportion of the public finds it difficult to do. I mean, some people can rub their stomach and pat their heads, whatever it is. Some people can't, you know. Some people are colorblind and some people aren't. And some people do this separation easily, but a few don't. And it doesn't mean there's anything wrong with them. It just means that you know, that's the way the public is. So there are some people who can't fuse the images, and people suffer sometimes from varying amounts of eye discomfort after doing that separation for a time. So this is something to watch. So if you are watching 3D television and you do feel some eye discomfort, of course, take the glasses off. You know that. It's only sensible. And tell your friends to do the same. So there we are. That's a rough explanation of how it works, and why we got so at the beginning of the discussion in the commercial module. And you know, as I said, we started to look at that level 1. You remember the compatible level, ITU level 1. And in this case, you have to make it work with a normal television set. So this means that you have to give the left and right picture different color casts and lay them on top of each other and broadcast the composite signal. And this is my wife again with a red cyan anaglyph picture. And this is the kind of thing that you see, as you know, if you buy or if you bought in the past a Blu-ray, which was 3D. You look at this with red and cyan glasses, and whoa, you see the vases and all that. And there's a book that she's holding which is actually poking out into the audience, if you could see that. Now, this was the traditional way of doing an anaglyph, but a couple of years ago, it was thought that another pair of complementary colors would produce a television picture that looked better to viewers without glasses. And these two complementary colors were amber and dark blue, and some broadcasts were done with them. You probably saw them. If you're in the United States or in the UK, Channel 4, NBC have used them for a police series and so on. And if you do this, you get not that, but you get this. And people argue that this is a little easier to look at if you don't have glasses. So it's a more compatible picture. I don't know what you think, but that was the situation when we started the work in the commercial module. This was about as good as you could do with a level 1 system. So we had our discussion and came to the conclusion that actually they may be used from time to time, they probably will, but systematically there doesn't seem to be a commercial demand for an anaglyph system because it changes the colors somewhat, so that it's not, if you will, as good as it could be if we use a more elaborate system. And even if there was a continuous demand for it, since it uses a normal TV set, we don't need any additional standardization to make it work. So we passed over level 1 level 2 in the ITU categorization. And what we find in the rest of this world, in level 2, 3, 4, is that 3D TV commercial requirements, as far as we can identify, fall into two major groups. These are two use cases, two areas where 3D television is needed and for which systems are needed. And the first group, and we've called this phase 1, is largely but not exclusively for pay television services, because their main need, their commercial need, is to preserve the use of existing set-top boxes in the 3D TV environment. If you have millions of set-top boxes in people's homes, you really, of course, want to keep them. So the public just has to buy a new display, keep the set-top box. This was, for them, as they saw it, the business case they needed, and this was the system we have to deliver to them. Just one thing is that it's these days you can do a modest software upgrade to a set-top box, and that would be okay. But that's basically it. That is phase 1. Set-top boxes that people have already got in their homes. And now that wasn't the only user area that was identified. We also identified a phase 2. And this is largely but not exclusively, the interest was expressed by free-to-air broadcasters. Of course, it's not 100% like this, and they had a different requirement because they don't have set-top boxes in people's homes that they must use, but they do sometimes use things like terrestrial broadcasting, where you need to be very frugal with your spectrum, and you can't really afford to have anything more than a single channel providing both 2D and 3D. So here in this phase 2, we are looking for a possible need to be able to watch a 2D version without needing an additional broadcast channel. There are other variations of phase 2. So really and truly, the difference between phase 1 is phase 1, set-top boxes that people have already bought. Phase 2, you encourage people to buy a new set-top box or built-in receiver decoder. That's the main distinction. So what we had to do was to develop two technical systems to meet these two requirements. Well, that's what we are doing, and we progressed quite well with phase 1, and we hope in the coming months to move to phase 2. So I'm mainly going to talk about phase 1 now, but with a few words about phase 2 as well. Now, for phase 2 to work, you have to have some things, and where is 3D heaven? Yes, I wonder that myself. So we passed through the conventional receiver, and we've said we don't need to standardize that. We're on phase 1. And to make this work, this means that you have to use an existing set-top box, so the picture that comes through it has to look to the set-top box like an HDTV signal. And there are several ways you can do that by squashing up the left and right pictures and putting them next to each other in different ways. And this process of making it look like an HDTV picture is called frame compatible. And there are sort of code words for the way you can do it, SBS and TAB, and I'll just show you those in a minute. But one of the important things to remember is that if we're going to use an existing set-top box, the broadcast has to pass right through the set-top box, because any unraveling is then done in the display, because you've got to buy a new one of those anyway. And the signal from the set-top boxes passes to the display via something called an HDMI connector. So the critical point for our design of our phase 1 system is that the broadcast signal must be what the HDMI can handle, because it goes right through the box and out the other side. Does that sound reasonable? So what we're talking about is a system which an HDMI connector, this is an industry standard for connections between the set-top box and the display, what it is that kind of system can handle. And this is one of the forms, the SBS, that's squashed Madam Wood there, squashed left and right. This is the side-by-side. And at first, it's not a watertight point, but because with the 1080i 1920 picture, you probably know there's a lot more horizontal resolution than vertical. So if you've got to squash something up, there's an argument that this is the best way to do it. And if you're using a progressive system, there is another one, top and bottom. That's what tab means. And again, but here you've got the slack is largely in the vertical resolution. So arguably, but not exclusively, this is the best way to do that. But there are arguments either way. So that's the SBS and the TAB. Now, what is it that the HDMI can handle? We go to the latest version of the HDMI specification. Those are the companies, the set makers who decide on these things. And what they have decided is that these are the formats that they guarantee they can handle in that connector, and of course that the display at the far end can handle them too. This doesn't mean this is the only option for frame compatible, but these are the ones that are guaranteed by HDMI at the moment. And so they are 720p, 50 and 60 top and bottom. That second one I showed you, 1080p top and bottom, and 1080i side by side. Well, that's probably what you would expect, isn't it? So these are the formats that we, amongst perhaps others, we could discuss that we have to deliver in our HDTV broadcasting system. And but just while we're there on the HDMI specification, there are some things which will affect phase 2 as well, because the connector also has several non-frame compatible 3D TV pictures, straight, left, right, and so these might be the ones that we would use for our phase 2. They are 720p, 50, 60, and 1080p 24. The 720p, 50, and 60 is there anyway, because this is what games manufacturers think is best. The 1080p 24 is there anyway, because that's what the Blu-ray people, the movie people, think is best for their products. So that's something that we're going to turn to when we get to phase 2. Okay, let's go on. And yes, we've done that. Conventional receiver compatible. I say these things many times, and then you hopefully might remember them. Frame compatible, the phase 1. Now, phase 2, actually, this is fairly complex, but there are several ways of doing phase 2. This is the one where you can have a new set-top box. One is that you can take a frame-compatible signal and add an enhancement to it. The other way is that you can do it like it's done in the Blu-ray, which is to have a 2D picture plus something else. And so those are the two ways, but we might need to remember that however way we do it, we have to hopefully be able to use the displays that people buy now, and that may be using those HDMI, the second set of formats. One of the issues is for phase 2 will be what has the Blu-ray done, and that uses what's called a service compatible. This is sometimes called a 2D plus something approach, and if you want the technical details, it's an AVC 2D image plus an MVC extension, and it's based on 1080p 24, and the left and right pictures pass over the 1.4A connector to the display. So that's the Blu-ray, and this might be a candidate for phase 2 broadcasting. That's a discussion that's very much still to be had. Okay, now back to our frame compatible options. Just to recap, left and right pictures fit into the frame, that's receivable on standard high definition set-top boxes. There are 3 basic options. There's another one there called offset subsampling, which can be used in combination with the other two, but the basic HDMI specs today is the first one, side by side, and top and bottom, as explained in the previous slide. Now these all have, as you saw, because they have to be squashed up a bit, horizontally or vertical, what we call reduced spectral occupancy. That means there's not as much resolution, perhaps, as there would be in a full resolution HDTV picture. But when you think of that, you have to remember that when you add the two on top of each other in a television picture, you actually get a higher quality than 2 separate pictures. So maybe it's not so bad. Okay, now phase 2, where are we? As I mentioned, this is the new set-top box phase. The base, one of the concepts, 2D plus something. The simplest type of something is a complete second channel. And then there are a number of other options that we'll be looking at in the coming months. And one of them is to use the Blu-ray system. And if you do that, you need a fairly large overhead for the something signal, but nevertheless, that may be the right thing to do. And another one is the frame compatible plus enhancement signal. And you So what you have to decide is whether you want to be compatible with 2D receivers or with phase 1 reception, and that's what will come into our discussions of the business case in the coming months. And but that can result in somewhat more spectrum, somewhat more resolution than phase 1, as you can imagine. So maybe, as it were, closer to a Blu-ray spectral occupancy in phase 2. Now, what we did was we've prepared some requirements for phase 1, and the basic things that they come down to in the frame compatible mode are just these two things: signaling, so you should provide what HDMI needs, the format, and so on, allow for future growth, and that the signaling has to pass through the display. There's a lot in the requirements document. We just agreed it in the subgroup a couple of days ago, and we'll be passing it up to our parent committee shortly. But that and this other thing of captioning, subtitles, and multimedia are the main things in the commercial requirements for frame compatible for our first phase. So I hope that's okay so far. Now I just have a few minutes pause when I give you a little bit something else, a bit of artistic stuff now, because this is unique. 3D is quite unique because it's not just the technical system which will determine eye comfort or eye discomfort. It's also uniquely to do with the way programs are shot, the framing, the way you place objects in a scene. So this time we have to worry not just about the technical stuff, but a bit about the artistic stuff now. And one of the interesting things that people do is to ask what kinds of programs are suitable for 3D television, because particular types of composition of actors and so on and cameras work better and lead to less eye discomfort than others. One of the things, though, with 3D is it's nice to have material that people want to take part in. So that means things like sports and so on, rather than stuff that they don't want to take part in. And you have to watch out, because if you're not careful, you can have all sorts of effects that make the 3D pictures look unnatural. Here's a few of them. And they're essentially caused by using either lenses which are inappropriate, camera spacing which are inappropriate, or scenes which are inappropriate. And just for fun, because we've actually been making 3D stuff since about 1850, haven't we? Is that we can look for guidelines about how to make 3D television. So about 100 years of 3D still photography. So here's, just for fun, a couple of pictures. So this is what stereo photographers think you need for maximum eye comfort and so on, maximum benefit with a 3D picture. Notice everything in the shot is in focus. There's a limited depth there, and if you place some objects quite close to the camera, and it's a wide angle lens, as you probably know if you're a photographer. Anyway, these are some more things. That is not my house there, but that is, I think that's somewhere in Dublin, 1870 or something. And that's a rather rude picture, but I'll pass on quickly for that. And that is not me in a swimming costume there on the right. But anyway, you're getting the picture. I hope that you have to have pictures which have fairly limited depth if you want to minimize eye comfort, and things that are quite close to the camera. So this is what it means. So-called point of view shots, the things as they would look from your eyes standing where you are, and there's a few technical details there. And people seem to think that these are the kind of things that would work best. This doesn't mean these are the only things, but a boxing match, a soap opera, that would be really great in 3D. And don't forget this one, by the way, this risk of eye discomfort, because eye strain is caused, or eye discomfort, when you ask your eyes to do something they don't normally do. And there can be many contributory factors here. If the left and right pictures are not exactly registered, or if the colors are not the same, retinal rivalry, or if you have the infinity points, as it's called, the objects that are right at the back of the scene, further apart than the distance between your eyes, so your eyes are pointing outwards, that is, believe me, not a comfortable thing to have to do. So there are many things which can cause eye discomfort, but there is one thing which is associated with the very process itself, and this is the need to separate focus and pointing, what I mentioned, and that is the one that you have to minimize by careful production grammar as we see it, and that is what we need your help to convince program makers that they must always be very careful with that, and we certainly hope there will be. There is one fascinating thing coming up in the coming months, as you probably know. Well, actually, it's starting the end of next week, which is the 2010 World Cup, which will be shot by Sony in 3D. And this is really quite a challenge because, as you saw, a lot of the things that associated with a football match may be difficult because the players will be so far away. So you get the cameras behind the goal mouth, it's going to look fantastic. But if they're trying to look at a player, the other side of the pitch, well, there's a lot of learning we've got to do, and the World Cup is going to be a great place to do it. So I hope you can find a club or whatever to have a look at the World Cup. Okay, so let's move on to our conclusions now of the commercial module work, and that is that we believe there is a clear commercial requirement for pay TV broadcasters for a frame-compatible 3D TV system. This is a system which can use the set-top boxes that people have already purchased. So when they start the service, they will need to buy a new display, but not a new set-top boxes. And this is very relevant and important if you have millions and millions of these set-top boxes in the public hands. In any event, the 3D displays will display quite happily 2D pictures, as you know if you've seen them, and people do change their displays, don't they, over time anyway. So that's the thing that we've been working on for some months, and what we've produced is the first set of commercial requirements in the subgroup that I'm responsible, and we'll be passing that to our parent committee later in June, and the DVB steering board after that, if they agree it. You probably know that if you know the system here at the DVB project. And the major things in our requirements is the signaling, because this is passing straight through the set-top box, now the other side, and how we cope with titles, subtitles, and things like that on the screen. You need some rules for that, and we may need a little bit, perhaps, for some software upgrades to the set-top boxes. So that's the job, and that is being done, will be done by the technical module, the TMC 3D TV group, led by David Daniels. And if you want to contact him, then please do so. And he's planning to break the work up into different parts, one which will be dealing with the subtitles and the captioning, another the general signaling, and a third part which will be to do with the formats that we're asking for. So we will have about 4 technical groups working on that over the coming months. The signaling and subtitles for the frame-compatible mode for Phase 1. HDMI allows SBS and TAB for Phase 1, and that's what they're in there. And, well, I'm hoping, don't shoot me if I'm wrong, that we will have a specification for Phase 1 by the end of this year, by the end of 2010. For Phase 2, you know, there are several options. One is an enhancement approach on Phase 1. That would be one way of doing it. And the other would be this service-compatible 2D plus something, the way that it's done today in a Blu-ray. And if you'd like to join that discussion, you're a DVB member, you're most welcome to do that. Go to the website, click on CM-3DTV, and join the group. So overall, thank you very much for staying with us this long. I think it's true to say, I hope you agree, that when we looked at the situation last year in 2009, really, we had a workshop here with the CM3D TV group, and it really looked like there was going to be fragmentation. There were lots and lots of different options, and everybody thought theirs was the best, of course. So last year, I think one could say that fragmentation looked like being a heavy ball and chain around the neck of 3D TV. But today, we know what we're doing, we know what the other standards bodies are doing, and we're close to our requirements for Phase 1. So I think I could be forgiven for saying the chain is a lot less heavy than it was. Ladies and gentlemen, thanks very much to my colleagues here, and to our secretary, Nigel Pankard, and to Sven Reuter, who keeps preparing timelines for our work and reminding us. Thank you very much for listening. If you have any questions, please put them on the chat or the questions. And so I just wait a minute for that, and if there aren't any, we can close our webinar. Oops. Yes. I think that would be there, wouldn't it? Or where would all the chats down here? Yes.
Do you see anything?
I don't know. So it seems that either you found it too much, or it was all clear. If you do have any questions or comments, please send us an email. But with that, ladies and gentlemen, thank you. Oh, sorry. There is something, isn't there?
Did you see that one?
I didn't know. I didn't. Is the presentation available for download? What's the answer, gentlemen? I think the answer is yes, Volker, and we will put a little button on the DVB website for that. Okay, so we will put that that presentation on the website, Volker. So if there are no more questions, we say thank you very much for listening and hope to see you at a future webinar. Thanks very much. Let's close. Oh, sorry. How about the audio, Rashad? Do you mean, Rashad, that the audio was? Oh, sorry, the whole thing. I'm with you now. Yes. What he's asking is, with 3D, you must be. Yes. You can see the 3D if you have color glasses, Rashad. Yes. So I think the idea is, should we put the whole presentation on the website? What do you think? Yes, my colleagues say yes. That would be that will be done. So the I think my colleague Desiree might have been a recording. 5.1 should be there. Oh yes, it's worth mentioning that of course 3D television wouldn't be complete without audio. In the discussions that we've had in the commercial module, I think although everybody has recognized that it would be nice if there could be a surround sound system which somehow gave clues to the sound field as it might exist behind the screen, that this is some technology that we simply don't have at the moment, and that the technology that we do have and use is 5.1 surround sound. So as it stands, the phase 1 is to be associated with 5.1 surround sound, just as HDTV is today. I'm sorry, Rashad, I wish there was more that we could do, and perhaps we'll persuade somebody with subsequent phases to provide a system which actually can give you sound clues to the field as it might exist behind the television screen. But it is an important point. Thank you for raising it. Oops. Last question, how do I get a copy of the presentation? I think that my colleagues here are going to put the presentation on the website, Rashad. So that's where it'll be. Okay. Thanks very much. I think we have spent our 40 minutes. Oh, and the website is www.dvb.org. I'm ashamed that you don't know that, Rashad. That should be, next to the National Lottery, emblazoned in your mind. Okay. Thanks very much then, ladies and gentlemen. We're closing the, yes, stop showing screen, press the red button. End webinar, that's it, yes.